Hey, geometry, here is 12-2 arcs and chords. Okay, so I'm sure you're looking at your packet thinking, wow, there's a lot to learn. Well, there is, but there isn't at the same time. It's like the same thing repeated in a different way with the same information for a few different things. And also the math behind this is actually really easy. The hardest thing we're going to do is the Pythagorean theorem. So if you can just understand a few of these properties, then we are going to be in good shape. All right? So let's get started here with this theorem 12-4. So it says congruent central angles, so this angle here and this angle here have congruent arcs. Okay, well we actually already knew that, but thanks for telling us again, so there we go. So if we have congruent central angles, then our arcs are also congruent. Perfect. Now, moving on to this guy here, congruent central angles, so again, our central angles, have congruent chords. All right, I think we can handle that. All a chord is, guys, is like from point A to point B, that's a chord, and C to D, which really should make sense. They're just connecting the endpoints of our arc, so they should obviously be congruent. So again, central angles have congruent chords. Now, scrolling down here, congruent chords have congruent arcs. Well, again, that should also make sense because if A and B are just the endpoints of our arc, and our chords are congruent, well, then obviously those arcs would be also congruent. So, congruent chords have congruent arcs. Got it, love it, have it down, right? Now, this last one here, chords that are equidistant. Okay, all it means is same distance from or away. For the center are congruent. So that's where you read that without breaking it up. So chords that are equidistant from the center are congruent. So here's my chord A, B, and here's my chord C, D. So since they are the same distance away, because they're telling us that by that segment mark, then therefore they are congruent. So A, B is congruent to C, D. All right? So I think either your assignment today will be helpful to keep your packet out with you so you can look at it, but let's try some examples together. All right? So here we go. The circles are congruent. What can we conclude? Let's just first see what we're given. So I have this chord GI and this chord LJ. Then they're telling us that this segment there is congruent to this segment there. Now that's our last property. That's saying that chords that are equidistant away from the center are congruent. I don't know why I wrote this out, but you can write it out. Or not, you can do what you wish. So, long story short there, we find GI is congruent to LJ. You probably could have just wrote that, but that's all right. So again, that's just because they are the same distance away from the center. Okay, now on this guy here, let's see what we're given. We're given that angle, that central angle WOX is congruent to angle EMY. So what do we know about central angles that are congruent? Well, we know a few things. We know that they have arcs that are congruent. So then we'll have WX, that arc is congruent to the arc ZY. And then we also know that they have congruent chords. So chord WX and chord ZY are also congruent. And that is because central angles are congruent. Peach, are we good? Okay, let's go on again. In-box algebra, again, not too hard. Let's just see what we're given and then figure out what we need to figure out. So it says find the value of x. Let's see what we know. Well, it looks like these chords here are congruent based on how far away they are from the center, because they're telling us that's congruent. So we're good there. they're saying that this chunk of this chord is 3.5, which is congruent to this chunk here. So what's 3.5 plus 3.5? Hope you're getting 7, because that's what I get. So that must mean x is 7. Because that chord, again, is congruent to this chord. Okay, now let's try another one. Again, we have a chord here and a chord here. They're telling us that they are equidistant away from the center. And then they're telling us that this chord here is 10, and x is just representing half of it, so what's half of 10? 5. So x equals 5, right? 10 over 2 is just 5. Now this last one here, we have, what do we have? So we have two chords that we're told are congruent based upon these little segments there. So that must mean they are equidistant away from the center. So if this one's 3.2, then x must also be 3.2. Alright? Again, watch this video if you have to again, or ask me questions since you're in class. Don't be confused and not do anything about it. So now we're going to move on to the next set of properties we have here. And literally all these properties are saying like the same thing, just in a different wording. So don't get too bent out of shape because there's 3. Really there's one with just different wording. Alright? So it says, if AB is a diameter, okay, we're good there, and is perpendicular to this chord, CD, then AB bisects this that arc and that chord actually. So we find that CE is congruent to DE because it bisects the chord, and then the arc is also bisected. So AD is congruent to CD. Okay, so I'll erase this so you can see it again. So all we have is our diameter bisects the chord and the arc. Okay, and it's perpendicular. Now this one says, if our diameter bisects our chord, then it must be perpendicular. Well, duh, you just said that. So again, if the diameter bisects the chord, hold that right there, then it's perpendicular to the chord. Great, thanks for telling us again. Now this last one here, the perpendicular bisector of a chord contains the center. Well, that is so true, because what do we know about a diameter? Diameter must go through the center. So again, if we have a diameter and is a perpendicular bisector to our chord, then obviously it goes through the center of the circle. So don't fret over these, just know at the end of the day, all I want you to take away from this whole page is that if you have a diameter and it is perpendicular to a chord, then it bisects the chord and the angle. Done. Don't worry about anything else. Now we just have some examples to go through. It says find x, round to the nearest tenth if you have to. Okay, so here we go. Well, really, we don't have a diameter here, but it would be the same if we did. So here is our diameter, and it's splitting here our chord. So all we really have right here is a right triangle, and we know how to solve right triangles. So our hypotenuse is 14, that likes 10. Now we can find x. So we're going to have x squared plus 10 squared equals 14 squared. Now just compute it. X squared plus 100 equals 196, not 296. Subtracting, x squared equals 96. We take the square root, x equals 9.8. Okay? Moving on to this middle guy here. So it looks like we're looking for a radius. That's all we're looking for here. Now, I'm taking that just half of this chord is 6, half of the chord 6, and this half must also be 6. So now we just have middle line here. right triangle. 4 squared plus 6 squared equals x squared. Now just compute. 16 plus 36 equals x squared. Adding those together, we get 52. Now taking the square root of 52, we find that to be 7.2. Then this last guy here, now don't get tripped up. This is just a radius, right? So I can put my radius anywhere because all radiuses are the same in a circle. So let's draw one this way. And would you look at that? Now I have a right triangle. Here's my side, 4.5. This side's 1.9. And there's x. So now just do the Pythagorean theorem. 1.9 squared plus 4.5 squared equals x squared. 1.9 is 3.61 plus 20.25 is x squared. Adding those together, 23.86. And taking the square root, we get x equal to 4.9. Yep, again, that was just straight Pythagorean theorem, guys. Just kind of having to look at a picture and decide what we needed to do. These ones get a little more interesting, but again, it's the same ideas. I'm just going to move them up for more space here. Okay, so now on this guy here, I'm going to call x just half of it. So this is my x. So I'm going to have 9 squared plus x squared equals 12. So we get 81 plus x squared equals 144. Now subtracting, x squared equals 63. Taking the square root, x equals 7.9. Alrighty. Now this next one, you have to get a little creative. All we're doing is solving a puzzle, guys. That's all we ever do, right? We're just solving a puzzle. So let's think about this. If this whole segment here is 24, then I know half of it is 12. So my radius is 12. And I know that this whole guy right here is 10. And half of that's 5. So let's just do a little of this. So this chunk right there is 5. Now ready for some magic? Look, here's a radius. Now here's another radius. And now we have a triangle, right? So let's label that that's 12. So now I just have a right triangle. 5 squared plus x squared equals 12 squared. 25 plus x squared equals 144. X squared equals 119. X equals 10.9. And then we have the same thing on this next guy here, guys. Again, all this segment is a radius, and I can draw a radius anywhere, right? So let's just move it this way here. So, and now we just have a right triangle. This guy's 4, and that piece right there is 10. So 4 squared plus 10 squared equals x squared. So then I have 16 plus 100 equals x squared. 116 equals x squared. Taking the square root, x equals 10.8. Okay, guys, we did it. We made it. Let me know if you have questions. Have us pack it out while you do your homework. Don't make it more complicated than it has to be. Let me know if you have questions.